Dear students, here we have Heisenberg's uncertainty principle here. So this is our discussion in this session. So now what exactly this uncertainty principle here? See, for very microscopic particles which are under motion, okay, so we cannot able to find exact position and exact momentum simultaneously. It means if you try to find, there will be some error in their measurements. Okay, so now that measurement, that error in the measurement will be considered as, see, if x is a position, let us say indication of position, and error will be, let us say delta x is the error in the position and delta p will be the error in the momentum. Okay, so this error, when we try to find the simultaneously position and momentum of a moving microscopic particle, will be get either error or uncertainty will be either greater than or equals to h by 4 pi. Okay, so the value of error or uncertainty will be around h by 4 pi times or 4 pi. Okay, so I hope it is clear where h is Planck's constant right now. So I hope it is clear. If not, let us consider we have an electron which is moving around the nucleus. Okay, something like the housefly moving like flying in front of you. Okay, so now if you try to capture that housefly, like let us consider that housefly as this electron. Okay, so now when you try to catch that, so what you will get? So you can able to capture that electron or that housefly at one certain point, but you cannot able to say in which direction or with what velocity is moving when you find its exact position. It means I can say, if you are unable to find its velocity, how can you find its momentum? Like product of mass into velocity, right? Momentum means. So if you do not know this, so we cannot find its momentum. Hope it is clear. And if you try to find its velocity with what velocity is moving, since velocity means it is under some motion, right now it is under some momentum. Okay, so you cannot get its exact position since it is under motion or since it is under some movement. Right now, hope it is clear. That means you cannot find exactly the position and momentum simultaneously or at a time. Okay, if you try to find, there will be some error in that. Okay, if you wanted to get this value without any error, let us say if you wanted to get the answer value having with zero error in its position. Okay, now what happens to its momentum? See, if zero error in position means, so momentum will be having some error, that will be, I am taking for numerical purpose, I am taking like equals to h by 4 pi. Okay, so now I can write this over here. So what is delta x value? You are saying error will be 0 in position. Therefore, if something is 0 here in the denominator, so something by 0 will be infinite. Na? It means error in momentum in this case will be infinite. If we are trying to find exact position, then there will be large uncertainty or large error in its momentum, or vice versa you can consider. So for example, if you want to find exact momentum without error, it means without error means delta p is 0. Delta p indicates error in momentum. Delta x indicates error in position or uncertainty in position. Okay, if you want error 0 in momentum, then what happens to error in the position? It will be becomes h by 4 pi into delta p, means this is again 0, means it is becoming infinite. So error in position is becoming infinite when you are trying to find with exact momentum. Hope this is clear. Okay, so how much error will be there? At least there will be h by 4 pi times, or 4 pi, h by 4 pi is a value of error when you try to find the exact momentum or exact position simultaneously with 0 errors. Okay, hope up to here it is clear. Now while solving the numericals, I will now show you what kind of numericals we can expect here. Okay, so now while solving the numericals, you just take it as delta x into delta p is equals to h by 4 pi, and you can do this. Okay, and you know, sometimes you can also give in terms of energies, delta E into delta T, energy and time. Okay, so this will be also h by 4 pi. Okay, like this also you can say. So now let us see few questions, basic questions on these. Okay, the uncertainty in the position and velocity of a particle are given like this respectively. The mass of the particle, see, very easy, we know delta x is a position, delta p is a momentum, and uncertainty will be either equal or greater than h by 4 pi. Okay, now momentum I can write, p I can write m into v, since mass of a particle will be constant, so upon derivation, I mean delta p, I can write m delta v, right? Yes, so put here delta x into m delta v, v represents velocity here, okay, h by 4 pi. So now what I want, so mass of this particle, so you can write h by 4 pi into delta x into delta v. Right now, so this is what the simple formula we can use here. Okay, so now what are the values given in the question? For the h we have 6.626 Planck's constant into 10 power minus 34 joule second, right? In the denominator 4 pi as it is I am writing, okay, into what about delta x given? See, the position is given as 10 power minus 10 meters, right? 10 power minus 10 meters, okay, into, and what about delta v or del v, or position uncertainty in velocity is given as 6.626 now, write that 6.626 by pi into 10 power minus 24 meter per second. Okay, I have written whatever the data mentioned there. Okay, now try to simplify this. See, it is very easy to simplify. See, 6.626 pi here, remove that. Okay, so now what about joule? You can write it as kg meter square second inverse square. Okay, so this meter and here meter, this meter square is removed. Okay, so second inverse, this second inverse square, this second inverse, and this second are removed. Now we have our answer in terms of kgs. Yes, so answer should be in kgs only. Now look at the remaining things. See, 10 power minus 10 power minus 24 means I can remove this 10 power minus 34, right? So what we are having now, finally we have 1 by 4 kg is will be our answer. Mass of that particle is 1 by 4 kg. So or you can write 0.25 kg. That's it. This will be your answer. Simple. So 0.25 is our first option. So take it as your answer for this question. Okay. Now let us move further with one more question. Yeah. So try to solve this question. According to Heisenberg's uncertainty principle, you can say HUP, Heisenberg's uncertainty principle, the product of uncertainties in position and velocity of an electron of mass given like this. So what I am asking, uncertainties in its position delta x and delta v, what is its value? Just give a try. So how do you try this? What is the formula we have? Delta v or delta x into delta v or delta p we have first. Okay, this is h by 4 pi we have. Right now, from this I want velocity here, as question is asking about velocity. So I can write m delta v as h by 4 pi. Okay, now delta x into delta v becomes how much? H by 4 pi m. Okay, so this particle mentioned here is what? Uncertainty principle of electron of mass given like this. So here you can take mass of electron. Now substitute all the constant values given here. So h 4 pi m and all. So what you will get? 6.626 into 10 power minus 34 joules second by 4 into 3.14 into 9.1 into 10 power minus 31 kg. Okay, so by simplifying this, you will be getting the answer as delta x into delta v. So by simplifying this, you will get 5.8 into 10 power minus 5 meter square second inverse as your answer. So this will be the value you should remember, because while doing the numericals, this value is very, very helpful. Okay, remember this value, we will discuss on this using this value itself now. Okay, so just remember what is the product of error in position and velocity, that will be equals to 5.8 into 10 power minus 5 meter square per second. Okay, this will be the value for electron. Okay, so remember this value. Yeah, so one more thing I just wanted to tell you. I want what is a product of position and momentum. So how do you get this? So h by 4 pi. So will you try to answer this question? What is the value of this constant h by 4 pi value here? Okay, just give a try. So just give a try. I am looking into it. So what you need to do? So just take h value as 6.626 into 10 power minus 34 joules. Okay, I am writing it as kg meter square and second inverse square into second by 4 into 3.14. Okay, so now see here, I can remove the second inverse square and the second. So by simplifying this, you will be getting answer as around 5.3 into 10 power minus 35 kg meter square second inverse. So try to remember these two values, the above one and here. Product of uncertainty in position and momentum is 5.3 into 10 power minus 35 kg meter square second inverse. This value you remember, and also along with that product of position and velocity is 5.8 into 10 power minus 5 meter square second inverse. These are the two values are very important while doing the numericals. Now I will be showing you one or two questions based on this thing only. Yes, look at this. We have a JEE Mains 2021 question. Just read the question what they are saying. Read it once. An accelerated electron has a speed of 5 into 10 power 6 meter per second with an uncertainty of 0.02%. The uncertainty in finding its location while in motion is dash. Find this value. How do we get? See, accelerated electron has a speed of this much. Okay, so speed is given this much, velocity is given with uncertainty of 0.02%. So what I can say, delta V, uncertainty in velocity, is equals to 5 into 10 power 6 meter per second into uncertainty given as 0.02%. 0.02 per 100 cent. Okay, so now remove these two zeros, and from here I can write 10 power 4, and this one is 5 into 2 into 10 power 4 into 10 power minus 2. I am taking it as 10. This is 10 power 2 remaining. So becomes what? 10 power 3. This is delta V. Hope it is clear up to here, right? So we got error in velocity. Now we need to know uncertainty in location. It means its position. So how do you find? Delta x into delta p is what? h by 4 pi. We have this now. So from momentum I can write delta x into m delta v equals to h by 4 pi, right now. So I want this value. Just now I have given you what I have given. So h by 4 pi m, mass of electron. When you substitute this, how much you got here? So look into the previous slide. See, h by 4 pi m. So you got this now 5.8 into 10 power minus 5 meter square per second. So use this value over there for simplification purpose. That's why I am saying you to remember that value. So what is that value? This is 5.8 into 10 power minus 5 meter square per second, and you know this value we got, and out of this we need to know only this delta x I want now. So delta x into delta v. V value we have delta v, that is 10 power 3. Okay, I am writing here, and this delta x we need to get here. So tell me how much it is. So 5.8 into 10 power minus 5, 10 power 3. I can write 10 power minus 8 meters. So this is in meters. So meter per second, meters, cancel, our answer will be in meters. So 5.8 into 10 power minus 8 meters we got. Okay, so they are asking us to express with 10 power 9 meters. So what I can make it, so I can just simply write it as 58 into 10 power minus 9 meters. This will be your answer. Hope it is clear that how we are solving this kind of questions. Right now, if it is clear, just click on the like button. Okay, now, so take a screenshot or just read the question, try to do it once again so that you will get practiced for this kind of model questions. Yeah. Next, here we have one more question based on this. So try to find this. Just give a try, everyone. I want answer from everyone for this. Yeah, look at here, the uncertainties in the velocities of two particles A, B are given. So means velocities, del V is given, del V of A is 5 into 10 power minus 2 I can write, 0.05 means, and del V of B is 0.02 means 2 into 10 power minus 2 I am writing, okay, respectively, and mass of B is 5 times mass of A. Okay, what is the ratio of uncertainties in their position? So we have del x, it means position, into m del v is equals to h by 4 pi. Right now this is the formula we know. Okay, so now using this formula, how can you do this? Just give a try. How do you do? See, for a particle I am writing xa multiplied with mass of A, ma, velocity error, Va, del Va, h by 4 pi. H by 4 pi is constant now, it is same in both cases. Okay, so here del xb, mb into del Vb, again here also h by 4 pi. So these values are constant, you can remove them. Okay, now what is the ratio we got? So I can write here, this is equals to 1. So delta x by delta xb into, so ma and mb relation is 5 times now. So I am writing here ma by 5 mb. Here we have for this 5 into 10 power minus 2, for this 2 into 10 power minus 2, okay, equals to 1. So look at here, so this is 5 times of mb is 5 times of ma, I am writing that. So remove these two things, so we got 5 here, so 5 also remove, 10 power minus 2, 10 power minus 2 removed. So what we are having now, del x a by del xb equals to 2 now, so send this 2 here, so this will be the answer. Hope it is clear how we got this answer. So just look at it once again. Just look at this. So how do we solve this? Okay, so now what we discussed, what are the formula just given? So just simple relation, this is a simple relation you should focus here in every of this question. Okay, so mostly this is a standard way of like standard questions, the standard models that we are seeing in JEE and NEET exams. Okay, and you know Heisenberg uncertainty principle works only for microscopic particle but not for the macroscopic particles. That is similar statement we will be studying in where de Broglie's hypothesis also. I hope you know about de Broglie's hypothesis. Okay, so by using this de Broglie's hypothesis and next Heisenberg uncertainty principle, we have quantum mechanical models. Right now, where we have studied quantum numbers from Schrodinger wave equation and all. Okay, so in the upcoming sessions, I will be doing these quantum numbers and quantum mechanical model. Okay, and how can we get hydrogen wave equation and all from that. So I will be explaining all those things. So stay connected with this channel, and if you have any queries, you can write in the chat box, or you can join our Telegram group also. Link will be in the description box. Okay, and yeah, so any other topic to be discussed, just mention to us in the chat box or in the Telegram group. We will be discussing about that. Okay, hope you have got some clarity over this Heisenberg uncertainty principle and approaching of questions. Okay, now we will be continuing our in the next session with the different topics. So stay connected with us. Thank you. Nice, nice.